Captain Peter Cutsey, Part 4, Adverse Weather, Cold Operations. We're in a holding pattern over an intersection called Ripan in the Belgrade, Serbia area, waiting for the to execute the approach to runway 30. That is a VOR approach to runway 30. We're in icing conditions. The temperature at the airport is minus 35 Celsius. And our briefing today is corrections, cold weather corrections. So let's get right into a PowerPoint that will help us look at this. Extremely cold temperatures create significant altimeter errors and greater potential for reduced terrain clearance. When the temperature is colder than ISA, true altitude will be lower than indicated altitude. Altimeter errors become significantly larger when the surface temperatures approach minus 30 or colder, and also become larger with increasing height above the altimeter reference source. Apply the altitude correction table when needed. Apply corrections to all published minimum, departure, en route, approach, including missed approach altitudes in accordance with the table. Advise ATC of the corrections. That point is most important because other people in the same airspace must make the same corrections. Otherwise, you will not have the separation required. MDA, NDA settings should also be set to the corrected minimum altitudes. To determine the correction from the altitude correction table, subtract field elevation from your barometric reference source from the published minimum altitude to determine the height above altimeter reference source when using the chart. We'll look at that in a minute. If the corrected indicated altitude to be flown is between 100-foot increments, set the MCP altitude to the closest 100-foot increment above the corrected indicated altitude to be flown. Enter the table with the airport temperature and the height above the altimeter reference source. Read the correction where these two entries intersect and add the correction to the published minimum altitude to be flown. There's a little note here also that the table only gives you as high as 3,000 feet. So if you're going up to, say, an altitude of 6,000 feet, you would double the correction used at 3,000. Now we'll have a look at the chart. The left-hand column talks about the airport temperature, not the temperature at the altitude that you're flying at. It's the airport field elevation temperature. In this case, we're using minus 35 at Belgrade, and we're somewhere in the 3,000-foot area. So our correction will be somewhere between 570 and 720. This takes time. This is an old, antiquated way to do it. However, if your company SOPs you must indicate you must follow the chart, then you use the chart. I'm sure you can convince them that there are other ways, better ways, and I'll show you that in a second. The actual formula that is used is here. I just did a little drawing here for you. You take the altitude you're flying at, and you subtract the field elevation, and you divide that figure by 1,000. And you take all of that, and you multiply that by 40. Then you take all of that and multiply that by 1/10. The difference between ISA, in this case 14.5 Celsius, and the temperature at the field, minus 35. That's what ABS means, is taking the difference. Very close, it's 49, very close to 50, 49.5. So you do all of that and you end up with your correction. In this case, it's somewhere around 542 feet, if I'm not mistaken. You round up always to the next 100. So your correction for 3,100 feet would be 600 feet. All right, let's have a look at some of these incredible apps that I'm talking about. This is PFMA menu, miscellaneous. You select it, cold temperature correction, and it gives you the fields to be filled in. It also has where the reference is coming from. So minus 35 is the field elevation temperature, and the airport elevation 337 ASL. And one of the altitudes is 3,100. Here it is, the TUPCO. The next is the final fix, 2,840. And the next is the minimum, 720. There are your corrected altitudes. Bingo, 3,700, 3,400, 800. You would add 50 feet to 800 and fly 850. Most airlines have you do that. All right. Here's another one. It's called FLYBY E6B. Super app and very accurate. So you pick altitude, you pick cold weather correction, and likewise you have fields to fill. So we'll fill them in, and you will get the resultant corrected altitude in the right-hand column here after we enter all data. So we'll put in altitudes, and then we'll put in the airport elevation and the airport temperature. Okay, so once we put in this data, we will have corrected settings here. So 337 minus 35, and bingo, there are the altitudes you fly. Okay. Also down here, the app actually made a chart. We'll have a look at it now. By selecting chart view, you'll end up having a good look at a built chart for you with the corrected altitudes. Wow. Isn't this the way to go? Let's have a look at Google Earth Terrain Profile before we get into a PDF file that I made on the approach for the vertical profile for the VOR. Google Earth is super accurate, and the terrain reference is what you would have in your terrain reference in your aircraft. It's the same. And if you have a vertical situation display, which we'll look at later when we actually fly the approach, it's super. However, the Google Earth presentation here, in what I constructed the approach in Google Earth to bring home a point. We're looking at TUPCO here, which is this point here, and it's 1,044. That is the terrain under the aircraft. Under TUPCO is 1,044 feet above sea level. That's the height of the terrain under the aircraft. So remember, you're flying a baro altimeter, and providing the baro altimeter setting is correct. So let's say the baro setting is correct. It's 993 right now at Belgrade, and we're at 3,100 feet. So 3,100 feet minus the 1,044 reference of the terrain under us should be what the RA, radio altimeter, reads. And we'll emphasize that, and I've done an entire video on vertical situation display and radio altimeter monitoring, which is very important. So remember that. Now let's go back and we'll actually have a look at the approach. This is the top side of third of the VOR 30 template, very current, 22nd of July 22 of this year. And we'll go down and have a look at the center portion, or the center third. So this is the actual chart. We're holding over Ripon. That's where we are here. You can see it's on the live map. And now let's go down and have a look at the vertical display, and something I drew out to explain the importance. All right. I'm using green because green is ISA, we'll say. So in this example, ISA is 14.5. Now let's say the temperature at the field is 14.5. Field elevation is 337 feet. Of course, you're not going to make any corrections. You don't need to. Your altimeter is correct only under ISA conditions. Remember that. There's the height of the terrain underneath the airplane. Here it is here. We saw it on Google Earth. That little point there, it's 1,043 feet above sea level. This isn't to scale. It's just something rough. Okay. By the final fix, which is the most important last part of your flight next to the landing, final fix, because it's your last chance to do a lot of neat things. Your last chance. You've got to check the charted altitude, barometric altitude, and make sure that the radio altimeter reading is what it should be when going by. If it isn't, you'd better go around. Also, at this point, you've got a beautiful wind vector on your nav display. That's where you call by the final fix, and you make sure you get a wind from the tower. Well, in our example, we're going to fly today. The wind at the surface is 210 degrees at 30 knots. The runway is dry, so it's a 90-degree crosswind. If the wind at your altitude on your little wind vector on your nav display is considerably different, you can expect wind shear. So final fix means last chance. All right, so this is ideal. So the green line is on the actual profile because it's ISA. Now let's have a boo at minus 35 degrees at the field. And you have made no corrections. And you're flying 3,100 feet, but your true altitude is not 3,100 feet. It's a lot lower. You're flying this amber vertical path. And look at your radio altimeter, 1457 versus 2,057. There's that 600-foot difference. So all your radio altimeter readings are wrong. They're correct. The radio altimeter is telling you this is real, but your barometric altimeter setting is wrong. You should be flying a higher altitude. Not the setting is wrong. The actual altitude is wrong. You have to fly a higher altitude in order to make good the real altitude. So let's go and have a look at the last little file here. This is the field temperature is minus 35, but we have corrected the altimeters properly. And if you notice, the blue line is right on the white line. Remember back on that first slide? Here, ISA conditions. Well, here we are with the blue line right on the correct path. And the only reason why it is we're flying 3,700 feet to make good a true altitude of 3,100 feet. We're flying 3,400 feet to make good a true altitude of 2,840. And we're going to fly 860, that's with an additional 50 feet. So you correct it first, then add 50 feet later. So there you go. That is important that you know that. All right, that's it for part 4. We'll actually fly the approach in part 5 and start to have a look at some of these settings. That is the radio altimeter readings. Thanks for watching. See you in the next video.